Hey guys, so this is just the first 10 minutes or so of the data science class on Wednesday, October 28th. That the recording wasn't on when I was using the doc cam, and so I thought I'd just kind of quickly walk through this handout which I had sent you guys a couple weeks ago. And so the purpose of this handout is just to introduce some of these different join functions, which is going to be our primary way of combining two different data sets in R. When you combine different data sets, you have to have some way to for R to know how to match up the rows. And the variable that we're going to use for how to match up those rows is called a key. And so in our example, the key is going to be the ID number for this first data set, DF1, and the key is going to be ID for the second data set, DF2. A key could really be anything. Like if you have two different data sets on maybe people in the data science class, in that case, the key would be the people's names. Or the key could be like a year if you have yearly data on two different things that you want to combine. So it could be many kind of different things. We're going to walk through four different join functions, which are called mutating joins, because they're going to end up adding variables from each of these to the same data set. The first is going to be a left join. And so each of these is also going to have this kind of corresponding Venn diagram. A left join is going to keep everything in data set 1. And so I'm shading the entire left side of this Venn diagram. The syntax for this, for all of these joins, is just going to be the names of the two data sets. So in this case, DF1 and DF2. And then this by argument, which is going to specify the key in each data set. So the key in the first data set is this ID num. In the second data set, the key is ID. What this is going to output is you might notice that there's some duplicate IDs. So one is duplicated in the first data set, and the ID number 2 is duplicated in the second data set. There's also IDs that aren't matched. And so the ID number 4 is in the first data set, but it's not in the second. And ID number 3 is in the second data set, but it's not in the first. And so the left join is going to definitely keep everything in data set 1. And so what it's going to look like is this first ID is going to get matched with a y-var of -1. This second is also going to get matched with the y-var of -1. This third ID number 2, because that's replicated twice in this data set, it's going to actually get matched with both of them in two separate rows. And then finally, since everything has to be kept in this first data set, this ID number 4 doesn't have a matching y variable because 4 isn't an ID in the second data set, so it gets kept, but the y-var is just missing. Okay. Right join, we're not going to do a full example, and we'll see why in a sec. Our Venn diagram for that, as you might guess, is that everything from the right data set is kept. And the reason we're not going to do this is because a right join, so that, I left off the by part, but so that is equivalent to a left join with just the two data sets flipped. For that reason, it's usually just easier to just always do left joins. And so you would never really need to do a right join if you could always just flip the two data sets and make it a left join. So we'll mostly ignore that. Inner join in our Venn diagram, as you might guess, is only going to keep observations that are in both data sets. That means that observation 4 and observation 3 are about to be cut when we do this inner join command. The nice thing about these join functions is that the syntax is identical, and so this is going to look exactly the same as the left join syntax verbatim. But what it's going to give as output is actually going to be the same as the left join, except now this last observation gets cut. And so there's our inner join. So again, same as the left join, but since 4 doesn't have a match, and we only want to keep stuff that's in both data sets, it gets cut. The last one that we'll talk about now, and these will be saved for Monday, the filtering joins. So the last one we'll talk about now is this full join. Again, these joins are made so that the syntax is identical, which is really nice. So again, we're just giving it the names of the data sets, and then this by argument that's going to let us know what the keys are in each data set. A full join, again, you might kind of be able to guess, is everything gets kept in both data sets, whether it has a match or not. And so what this is going to look like is it's going to actually start out the same as that left join. But now this 4 is going to get kept, just like it did for the left join. And since we want everything to get kept, this 3 is also going to be kept. And the xvar for 3 is going to be missing. All right, and so that's, since we're ignoring right join, that's really 3 different ways you could think about combining data sets. Which one is the one you want will depend on the context. And so sometimes you might want to keep everything in the first data set, but drop anything that's missing from the second data set. Sometimes you only want to keep observations that have IDs in both. And sometimes you want to keep everything no matter what, whether it has an ID in the other data set or not. Okay, so from here, this should pick up with the RStudio stuff in the Zoom video.